Students, last class we studied about Nyquist criterion, Nyquist plot, Nyquist contour. Okay, so today we are going to do some of the problems related to that. So then you will clearly understand what is Nyquist plot, Nyquist contour, all those things. And I feel that it is not very difficult to understand. So all the videos I had given, you should go through it minimum 2 times. Then only you slowly go through it. You open the text with you. Already I had given the soft copy of text. You can use that, and using that, you can understand very clearly what I taught. So here, what I want to see that, what I want to tell that, last class some correction I need to do, that is related to the Nyquist contour. Related to the Nyquist contour, I pronounced it as some tau. Tau sign is almost similar to this. Okay, so this is it is gamma. This is not a tau, it is a gamma. So just do the corrections. It is gamma GH. It is a capital letter of gamma in Greek. You know, small letter gamma that we are frequently using. We are not familiar with the capital letter, but here you can see that it is a capital letter of gamma. So it is gamma GH. That is the correction you need to do. Apart from that, today we are going to do the problems. So here it is 8.1 is a problem related to all the variables are not real variables. As you can see that, no, it is not a, it is all the parameters are variables. So it is, I don't want to do this. If you want, you can go through this, because in order to understand the problem, we will take 8.2. So here the parameters are, it is not a variable. Okay, some of the the parameters. So draw the Nyquist plot and assess the stability of the closed loop system whose open loop transfer function is g of s into h of s is s plus 4 divided by s plus 1 into s minus 1. When you are observing this transfer function, you can see that there is 1 0 and 2 pole, and the pole locations can be found by equating the term to 0. So first one is s plus 1 is 0, so s is at minus 1. Second one is s minus 1 is equal to 0, so s is equal to plus 1. So you can understand that there is one pole that located at the right half of S plane. So eventually you can understand that this open loop transfer function shows that it is unstable because there is a pole at the right half of S plane. So we will check what about the closed loop transfer function, whether it is stable or not. Now from the transfer function of the open loop system, we observe that there is one open loop pole in the right half of S plane. So the open loop system is unstable. So here P is equal to 1. So for the closed loop system to be stable, the Nyquist plot of g of s into h of s must encircle the minus 1 plus j0 point of q of s plane once in the counterclockwise directions. So here, the closed loop system to be stable, what is the condition? The Nyquist plot of g of s into h of s must encircle the minus 1 plus j0 that I explained in the last class point of q of s plane once the counterclockwise directions. So here we are dealing with open loop transfer function. We are not dealing with the closed loop transfer function. If we are dealing with open loop transfer function, we have to consider about the point minus 1, 0. But if we are dealing with closed loop transfer function, it is purely related to the origin. So last class we observed that these two graphs are identical. The thick graph is related to closed loop and the dotted graph is represented open loop. Instead of doing this closed loop, we can do the open loop provided that the contour should be oriented about minus 1 plus j0. Okay, so here that is a prime important point you have to see. So here when you are observing it, P is nothing but number of poles on the right half of S plane, and here number of zeros on the right half, there is no zeros. When you are observing this graph, this expression, you can see that s plus 4 is equal to 0, s is equal to minus 4. So 0 is located on the left half of S plane. So there is no zeros of the open loop transfer function at the right half of S plane. So z is equal to 0, but p is equal to 1. So the closed loop system to be stable, the Nyquist plot of g of s and h of s must encircle minus 1 plus j0 point of q of s plane once in the counterclockwise direction. So we analyze this. So here g of s, h of s in sinusoidal form, we have to first make it to sinusoidal form, that is g j omega h j omega by changing s to j omega. So we are getting it as j omega plus 4 divided by j omega plus 1, j omega minus 1. This we are rewriting in such a way that we are taking minus, it is in the form of real part first, then imaginary parts second. So we will get 4 plus j omega and 1 plus j omega, and here we are taking second term, we are taking the minus outside, so 1 minus j omega, so you are getting a minus sign here. Now this same expression 4 plus j omega, then you are cross multiplying these two terms, you will get a 1 plus a minus b into a plus b, that is a square minus b square. So here you will get 1 minus j omega all square. Here j square itself is minus, j square is minus 1. So minus of minus omega square, that is equal to plus omega square. So you are getting 4 plus j omega divided by 4 plus omega square. Now we are splitting this into, there is a whole having a minus term. So that minus term we are keeping as it is. So we are splitting this into real and imaginary terms. So it is minus 4 divided by 1 plus omega square minus j omega divided by 1 plus omega square. Now along the segment, so we have to see the Nyquist contour. We have to see the Nyquist contour. So we have to see C1, for C1, what happened to your, what is the relation between C1 and your closed loop transfer function, and what about C2 and your closed loop transfer function. So that we analyze now. Now along the segment C1, the Nyquist contour on the j omega axis. You know that already, you know that. Along the segment C1, Nyquist contour is on j omega axis. Okay. Yeah. Along the segment C1, the Nyquist contour on the j omega axis, S varies from minus j infinity to plus j infinity. So you have to study this contour perfectly, Nyquist contour. S varies from minus j infinity to plus j infinity to minus j infinity. Okay, or minus j infinity to plus j infinity. So S varies from minus j infinity to plus j infinity at omega is equal to. So now we will see what happened at minus omega infinity and at plus omega. At omega is equal to minus infinity. So you have to substitute that in this term. So g j omega, h j omega, minus you are taking minus 4 divided by 1 plus minus omega. Omega is nothing but minus infinity. So minus infinity square minus j omega minus infinity 1 plus again minus infinity square. So you are getting some term divided by infinity 1 plus infinity square. It is again infinity only. Some term divided by infinity, it is minus 0. And here minus of minus, it become plus. So you will get a infinity square, infinity divided by infinity square, 1 infinity cancel. So 1 divided by infinity is this again 0. So you are getting minus 0 plus j0. So it is very easy to do. So all of you concentrate. Next we will see omega at 0. Now we set 0 minus. So just here one stated one we just now it is our omega is equal to minus infinity, and another is omega is equal to just below this, that is minus 0. And after that we will take omega is equal to plus 0 and omega is equal to plus infinity. So we will see what happened to your expressions. So when omega is equal to 0 minus j omega h j omega is equal to, you substitute minus 4, 1 plus minus 0, wherever omega you substitute minus 0, 0 square minus j minus 0, 1 plus minus 0 square. So here 0 square is 0 itself. So minus 4 divided by 1 it will come. So it is minus 4. Here minus and minus, and that become plus j0. So here 0 divided by 1 it will come. So it is plus j0. Now when omega is equal to plus 0 plus g j omega h j omega, substitute 0 as plus 0. So minus 4, that is, as you can see here, just above this line, and we will take here like that. So at omega is equal to 0 plus g j omega h j omega is equal to minus 4 divided by 1 plus plus 0 square minus j plus 0, 1 plus 0 square. So here this plus 0 square is 0 only, this also 0 only, but here minus 4 divided by 1, that is minus 4, minus j plus 0, so it become minus j0 only. Now at omega is equal to plus infinity, at omega is equal to plus infinity, what happened? When omega is equal to plus infinity, gj omega, hj omega is equal to minus 4 divided by 1 plus infinity square minus j plus infinity divided by 1 plus infinity square. So 1 plus infinity square, it become infinity square. Here also infinity square. So 4 divided by some infinity, it is minus term is the minus 0. Here it is minus infinity and infinity square. 1 infinity cancels. So 1 divided by infinity. So it is equal to minus j0. So you get minus 0 minus j0. So we get 4 points to draw the approximate Nyquist plot. Now we have to see the semicircular arc. This semicircular arc, how it is. So here, as you can see that r e to the power of j pi, where r is tending to infinity. So what happened to that? We have to see that. So now, so here, so we get 4 points to draw the Nyquist, approximate Nyquist plot. Along the semicircular arc of the Nyquist contour, S is equal to r e to the power of j pi, where r tending to infinity, pi varying from plus 90 degree through 0 degree to minus 90 degree. So already I told that when pi is equal to 0, we are getting here. Pi is equal to plus 90 degree, you will get this point. Pi is equal to minus 90 degree, we are getting here. So it is vary from minus 90 to 0 to plus 90. So it is mapped into g of s into h of s, limit r tending to infinity. You have to substitute in your expressions. So this is your expressions. Yeah, this is your expressions. There you have to substitute. First expression is s plus 4 divided by s plus 1. And, so wherever s you have to substitute r e to the power of j pi. In that limit r tending to infinity, you have to find it. So you will put instead of s, you put r into e to the power of j pi plus 4 divided by r into e to the power of j pi minus 1, r into j pi plus 1. So this one, when you are analyzing it, when you are multiplying it, here you will get a r into e to the power of j pi square you will get. Here you are getting r into j pi e to the power of j pi. So when you are cancelling, the net effect will be limit of r tending to infinity 1 divided by r into e to the power of j5. You can eliminate the constant terms. So it is limit of r. We are concerning about r. So r related terms you have to consider it. So numerator you will get a r into the power of j pi. Denominator you are having r into the r into to the power of j pi square. So at the denominator you can see that 1 divided by r into to the power of j pi. So limit r tending to infinity. So 1 by r, 1 by r, r tending to infinity becomes 0. This you can take to the on the numerator e to the power of, here it is plus j pi. If you are taking to the numerator, it become minus j pi. That is the origin of that is the origin of the g of s h of s plane with radius, this r tending to radius. Okay, so that means r is always 0. It is not the arc. So you can see that this is nothing but r. So this become 0. So it is situated in 0 only. So this will be in 0 only. R is equal to 0. And g of s into h of s locus thus turns at the origin with a 0 radius from minus 90 through 0 to plus 90 degree. So that is radius is 0. Now, based on the above information, an approximate Nyquist plot is drawn as shown in figure. So based on this, yes. So this is the based on. So this will be the Nyquist contour. Okay. Here j plus 0, omega is equal to 0 plus. Here it is omega is equal to 0 minus. Here omega is equal to minus infinity. Here omega is equal to infinity for C1 and arc C2, that is r into e to the power of j pi, where r tending to infinity. Pi varies from minus 90 to 0 to plus 90. This is in S plane, sigma to j omega. Now if we are coming into u into jv, that is in QS plane, that is corresponding Nyquist plot. This is Nyquist contour of and corresponding Nyquist plot for g of s, h of s, that is s plus 4 divided by s plus 1 into s minus 1. You can observe here. So when you have to plot according to this, okay, you have to plot according to this. When omega is equal to minus infinity, you are getting 0 plus 0. Omega is equal to minus infinity, you are getting omega is equal to minus infinity, you are getting minus 0 plus j0 on the top point, minus 0. Minus 0 means real axis minus 0 and plus j0 just above this, slightly just. Okay, plus j0 means this, when omega is equal to minus infinity. And when omega is equal to plus infinity, it is minus 0 minus j0. That is represented here. That is represented here. When omega is equal to plus infinity, you are getting minus 0 minus j0, just below this. Same point 0 only, but we are representing this too. Okay. Yeah. And this is u and jv. Now, omega is equal to minus infinity. Yes. Now, omega is equal to, see the contour is how it is drawing from minus infinity to 0, then 0 to plus infinity. So I can say that minus infinity to minus 0, then plus 0 to plus infinity. That is the path. Then using the angle. So here, as you can see that you got minus infinity, you got minus 0 plus j0. Next, omega is minus 0. Omega is equal to 0 minus or minus 0. That time you are getting minus or plus 0. So you are getting minus 4 plus j0. So here minus 4 plus 0 for omega is equal to 0. Next is, so the angle, see, you are starting drawing from minus infinity to minus 0 minus, then plus 0. Plus 0 again, minus 4 minus j0. Plus 0, you are getting minus 4 minus j0. So you can see that this same point only, minus 4 plus 0 and minus 4 minus j0, both are the same point only, but slightly above and down you represent it with an arrow. Okay, and it is you can see how it is traveling. When omega is equal to minus infinity, we start. Then omega is equal to 0 degree. 0 minus, then omega is equal to 0 plus, then omega is equal to infinity. When omega is equal to infinity, it is minus 0 minus j0. So it will come to the down point. From the up point it starts to here, then down point starts. This contour shape is not important, but here, since it is an open loop transfer functions, we need to consider that if whether the contour encircles minus 1 plus j0, if it encircles in a counterclockwise direction, then the system is stable. And what about the arc? We observed that the arc radius is 0, so that we cannot represent anything. It is 0. Radius is 0, so it is with a radius of 0. And when the angle varies from minus 90 to plus 90, the arc is 0 only. Okay, so this way, omega from minus 0, minus infinity to minus 0, then plus 0, then plus infinity. So this way the omega increases. So the angle is now the direction is counterclockwise. So we can say that based on the information, an approximate Nyquist plot is shown in figure B. It indicates that the minus 1 plus 0 point is encircled by this locus once in the counterclockwise direction. So the closed loop system is stable. So try to understand this problem. 2 times you go through it. So we will analyze the subsequent problems. Then you will get the idea how to solve this. This is not very difficult. It is very easy. You can easily score marks in this unit. So all you should concentrate this type of problem. Okay, please do and go through it more than one time.